Hello, my name is Damien Joshua Levadas, and today I'll be demonstrating the functionality of part 3 for our synthesizing of a waveform. So a little bit about what's going on here. We have our microcontroller here that's being fed a program that is giving multiple outputs for a port. In this case we have port C, and those outputs are being fed into the DAC as inputs. And that DAC is outputting that certain time voltage in running through here. It is being connected to our oscilloscope here. So as you can clearly see, the oscilloscope is reading the output of the DAC, and we have a banana clip, our second connection on our oscilloscope wire, connected to ground. So for the synthesizing waveform I have function C. So essentially what is going on here is that we're going from 0 all the way up to 3, which is our maximum peak, goes down to 0, comes back up 1.5, which is half of this, and goes back to 0. So as you can see here in the oscilloscope, we have exactly that. Now, in accordance to our function C, here our time ends at 1120. As you can see here, we already have our cursors on for time. Our delta time is here at 1.132 milliseconds, but if you converted that to microseconds, you would see that it is 1130, which is 1130, which is extremely close to what we got. Now, in order to measure the voltage to make sure our peaks are according to what we need, you go voltage here, you clear any measurements you already have, and here you can go to cursor and click V1. So V1 we automatically set to the bottom, and then you just click V2. As you can see here, our delta V is at 3.1, which is very close to 3, which is our maximum voltage for our first sine wave. And now we move this cursor down to go to the other sine wave. We could see that right at that peak, you have 1.5 volts, which is exactly according to what we need to deem this microcontroller and our DAC output correctly synthesizing the waveform that we were given to by the instructor. Thank you.